Let's see this analog interview question. First they have asked us to find the op-amp terminals for negative feedback, then find Vout. Okay, first we will try to find the negative feedback terminals. Okay, first we'll draw the circuit. Okay, first for finding the terminals, first we need to break the loop. We will break the loop here and then we will find the terminals. First let us increase the voltage at this node. If we increase the voltage, this is Vg, we are increasing Vg, the current flowing. Let us take few assumptions to analyze this circuit. First assumption is lambda is equal to 0, and second one is gain of the op-amp is infinite. These are the two assumptions. Let's take. If Vg increases, what is current flowing through it is Gm into Vgs. So if Vg increases, this current will also be increasing. Current flow in this direction, so the voltage drop will be something like this. This node the voltage will be increasing, right? This node the voltage is increasing. If the voltage at this node increasing means here it is increasing means, now in the question they have given us negative feedback, right? Negative feedback. So for negative feedback, if this is increasing, the output should be decreasing, then only it will be negative feedback. So for that to happen, this terminal need to be negative and this terminal to be positive. So it will be something like Vn minus this Vx, let's say this as Vx into A will be our thing. Okay, since it has negative and Vn has positive. Now we got the terminals of the op-amp. Let's find the Vout. As we discussed earlier, the gain here is infinite, so and it is negative feedback, right? So we can apply virtual short concept. Now if we see, let's say this voltage as Vx, then the current flowing in this will be, let's say some I. This I can be equal to, that I can be equal to Vgs. Vgs means Vg, this is S, right? G is Vx minus S means since the gain is infinite, virtual short concept apply here and it will become Vn. So it will be Vn. This is Vgs into Gm. Gm is common. Now let's apply small signal equivalent. In the small signal equivalent, this will be grounded. So the Vout will be, current is flowing in this direction, so it will give plus here minus here. So this is the Vout we will be getting. Negative. Let's write the equation for Vout. Vout can be equal to minus that current into R2. Okay, this can be Vout. Now let's try to get this I in terms of Vn and all the things. So we need to remove Vx. To remove that, we can say that the current flowing here will be Vn divided by R1, right? The same I current is Vn divided by R1. So we can equate the both of things, like Vx minus Vn into Gm can be equated to Vn divided by R1. If we rearrange the things, then Vx can be equal to, this thing will go here, multiplication and subtraction, so it will be Vn. If we take Vn common, it will be 1 by Gm R1 plus 1. This is the equation we will get for Vx. Now if we put this Vx in that I term, we will get the current I. I will be equal to, again here also if we take Vn as common, I am doing it directly, you can work it out. If we take Vn common, then we will get 1 divided by Gm R1 plus 1 minus 1 into Gm. These two get cancelled and after getting multiplied this Gm and this Gm will get cancelled. So current I will be Vn divided by R1 is the current I. So now our Vout will be equal to minus of Vn into R2 divided by R1. This is the answer. Okay.